Hey everyone, welcome back to another video. And in today's video, we're going to be covering an interesting topic. It's called the nth roots of unity. Okay? So, now before starting this topic, I just want to let you know that this topic is related to complex numbers. Now you're gonna learn about what the nth roots, what unity means, why it's called the nth roots of unity, and what it means. So let's start. Okay. So when we're starting this kind of equations, nth roots of unity means it means this. The values. Let's try meaning. Meaning. Yeah. So. Meaning the values of n which satisfy okay, so basically the nth root of unity means the values of n which satisfy z raised to the power of n equals 1, where z could be any complex number. Okay? So different types like the cube roots of unity, fourth roots of unity, fifth roots of unity. Okay? And the thing is, when the solutions to this are complex. That's why it's a complex number. Alright? So let's start with something. Let's start with the square roots. No, there are different types of roots. So the square roots of unity mean it just means that what power of z squared equals 1. And you might be thinking the solutions to this are just real. Z is equal to plus minus 1. Okay? So that means z could be equal to 1 or z could be equal to negative 1. These are two solutions, right? Because when we take the square root on both sides, we put the plus minus sign here, and then we get two complex solutions. The reason these are complex because we can write this as 1 plus 0i, and we can write this as negative 1 plus 0i. That's why these are complex solutions. So this is a basic equation, right? It doesn't seem too difficult. Alright? But now, let's dive into something called the cube roots of unity, okay? And then now, I'll explain why it's called unity, okay? Alright? And one more thing. We can think of this as like this. Suppose this is unity. We could think of it like this, okay? Yeah. Or yeah. So it's the same thing. What we did is we just took the nth root on both sides, and in this case, it's just like we can think of it like as this also, right? Because the nth roots of unity, nth roots, this is the word unity, and the reason it's a unity because I'm gonna show the complex plane because. Oh, yeah, that's right here. Why? Unity. Because the roots are placed They're placed equally. Yeah. Yeah, around the unit circle. They're placed equally. This is the main reason, okay? And I'll show you. That's why think of it as united. They're placed equally around the unit circle. Okay? I'll show you like this, okay? That's how it is. So now let's talk about the cube roots. Okay, I think I should erase this first. Then we can talk about this. So I can shoot up to here. Yeah. That's basically what's going on here. Okay? Just the, yeah. Alright? Now this is interesting. Let's talk about this. Cube roots. Okay? So look. What's happening here is basically, it's something like this. Z cubed. Let's use this one. Z cubed equals 1. Now let's think about this. Usually what people will do is they'll take the cube roots on both sides. Like this. And this is not wrong. Because from this, you get Z is equal to 1. But this is only one. This is only one of the 3 complex roots. Because the thing is, when you take the square root, the thing is, when you take the nth roots like this, it only gives us the real solution. Like if you solve an equation like the second nth root. So the thing is, if we have to use our brains a little. So we want to find the other solutions, okay? So let's solve this step by step. Okay? So here, let's solve here. Z cubed is equal to 1. Now I'm gonna do this, okay? I'm gonna shift this to the other side. So Z cubed minus 1 is equal to 0. And did you notice that we can also write 1 as 1 cubed? Yeah, it's true. I know this is the difference of cubes. Okay? Let's write the difference of cubes. And there's a formula. Yeah. So it'll be A minus B into A plus AB, yeah, plus B. Let's plug the values in. So we would get from here, then we do the factorization, Z minus 1, or this should be squared, yeah. Okay, into Z squared, okay, plus Z squared plus Z, because Z into 1 is Z, and B squared, yeah, it will be 1. Yeah, because in this case, we have A is equal to Z, and B is equal to -1. Okay, so just gonna plug this in. And we're gonna set this equal to 0. Now we can set each factor to be equal to 0. It's the 0 product rule. Yeah, 0 product rule. Yeah, because we can just set Z minus 1 equals 0, and we can set Z squared plus Z plus 1 equals 0. Now when we solve these equations, we'll get 3 roots. Because this is a square, so we're gonna get 2 solutions with 1. Yeah. So, like, it's like A, if you have any number, if, yeah, like A, yeah, like if we have two terms, A, B, then yeah, it is important because we're using this. I'll just write polynomial because when we say polynomial, we're also including monomials, binomials, and trinomials, and above. Okay, so this is the product now. Yeah, and yes, if we have three terms, we'll just set the three terms equal to 0. It doesn't matter because multiplying by 0 just gives 0. Okay, now to solve this equation, from here we can just add 1 to both sides. We'll get equals to 1. Okay, good. Now this is what we originally. Okay, and then from here, let's all use the completing the square. So completing the square, z squared plus z, move this other side, and then after that we're gonna add. Look, a is equal to 1, b is equal to 1, c is equal to 1. Okay? So look. So now what we're gonna do is, now we're gonna add b. No, we're gonna multiply both sides by 4a. So 4a will be 4 because this is 1. 4 into a, which is 4. Okay. Okay. Then we get 4z squared plus 4z equals -4. After this, we're gonna add b squared, which is 1 to both sides. So we're gonna get 4z squared plus 4z plus 1 equals -4 plus 1, you get -3. Okay? Now what I want to do is, we can factor this. Because there's another formula coming in mind. Let me just erase this to make some space. No, I can just make it out. I should erase this, okay? Just note this down, okay? Okay, all good so far? Alright, so now let's put an arrow. Okay, not too big. It's just right here. Okay? So now we could factor this. 2 into z. I should write it here. A little higher, I think. Yeah. So look, this is an identity. We can write this as 2z squared plus plus 1 squared. We can add any order. Plus a squared plus b squared plus plus 2 into a and b. This is the identity. This is the a plus b whole square is equal to a squared plus b squared plus 2ab. We can factor this. We can simplify this. This is the identity. This is the identity we're using. The factorization formula. Okay. So now let's come down a little bit. Okay. Then we can write this as 2z plus 1, given the formula, a plus b whole squared, plus 1 squared, will give us -3. Okay, we have to take the square root on both sides. Okay. So, square root. And one more thing. When you're taking the square -3, be sure to put the plus minus sign. So the plus or minus the square root of -3. Now this is imaginary. We get So when we take the square root, let me just differentiate, just show, like this. Now, we'll take the square root, okay, on both sides. Okay, so you can see the operation clearly. Plus minus. Okay. Now we see something. This will cancel. The radical on the square. Because we can write the square root as, because raising to the power of 1, 2. Because the thing is, when we have, like, when we square this, we're squaring this, right? Now when we take the square root, we can write this as raising to the power of 1, 2. Then we can multiply this, and when we multiply this, we'll cancel, we get 1. Okay? Because we multiply the powers. So that's why, taking the square root, we just cancel the radical on that, and the square root is cancelled. Okay? So now, this cancel, this, and this one, yeah. Now this one, this is interesting, because we can see the square root, look, 2z plus 1 is equal to plus or minus I until root 3. Why this? Because if we have the square root of any negative number, we can open the value of I, because I is equal to the square of negative 1. And the square of negative 1 into the square into the square root of 3 will be the square root of negative 3. So we can write it as this. Or you know what? We can write as an imaginary number like this. The square root of 3 into I. Now this is in the standard form of an imaginary number. Pretty cool, right? Okay. Now 2z equals plus minus the square root of 3 of I minus 1. Then we're going to divide 2 on both sides. Okay. This will cancel. Let's erase that. Okay. And now we get z is equal to plus minus. Let's simplify this a little bit. So plus minus the square root of 3i minus 1. Now, let's see here. I can write like this, right? Look. Now we have 2. We have to consider 2 possibilities. I think I should erase this for now. I don't have any space yet. Okay, let's erase this. Yeah. Alright, so now we have 2 possibilities. Z can be equal to the positive square root of 3 into I minus 1 upon 2, or z equals negative minus 1 times the square root of 3 times I minus 1 upon 2. Okay? And there you have it. These are our 2 roots of this equation. And if you want, we can write it in the form of a plus bi. So, okay, so let me erase all this so we can write the final solution. Okay? So what do we get here? We can write this. So in this case, alright. So in this case, z is equal to I into root 3 upon 2 minus 1 upon 2. Okay? Or you can write this as negative I into square root of 3 upon 2 minus 1 upon 2. Okay? Now, there's something you should notice. It's that when you see, Okay, we can write this. We want to make a conjugate. So this is, yeah. Look, we can write this as yeah. So negative I into root 3 minus 1 upon 2. We can factor the negative. So negative I into root 3, okay, plus 1 upon 2. Alright. So then, now we have negative 1 into this. Abdeko. Now what we have is, now, let me just erase this for space. Okay, so now what we have is, look, in this case, we have negative 1 into I into root 3 plus 1 upon 2. Okay, well, we can write this as negative, yeah. Hey, 1 second. Yeah, negative 1 upon 2 into this. I into root 3 plus 1. No, that's not necessary. What the hell? Okay, wait. 1 second, guys. Basically, these are the roots. Okay? So you might be thinking that these are the roots. Equals I into root 3. Okay? Alright, good. Now we've successfully found the roots of the equation. Okay? So now, it's pretty jolly now. Wait. Give me a second, guys. Okay, guys, I'm back. So I just realized I just confused myself for no reason. So I was going to convert this into the form of a plus bi. And as you can see, these are conjugates. This is plus, this is minus. So I'm going to rewrite this into the form of a plus bi. Okay? Because it looks better that way. So we can rewrite this as negative 1 upon 2 plus the square root of 3 upon 2i and negative 1 upon 2 minus the square root of 3 upon 2i. Good? Okay, so now these are the cube roots of unity. So the cube roots are here. Z equals 1, negative 1 upon 2 plus the square root of 3 upon 2i and negative 1 upon 2 minus the square root of 3 upon 2i. Here are your 3 roots. You might be thinking, why are they called the cube roots of unity? But this is something I want to show, that we can also rewrite this as, that this is 1. Oh. This is 1. Yeah. This is omega. And this is omega squared. Now look. This is something new we're going to learn. Is omega. Now, the thing is, it's a special name. And look, there's something special about this. Here. Note. Yeah. So omega, it's like a W, like this. So omega and omega squared are the primitive, okay, so they're the primitive cube roots of unity. something pretty sure know. Okay? So these are the three roots we have to this equation. And the reason this is omega, because when you square this, you're gonna get this. You're gonna get this. Because if you square, you can try it. It works. Okay? So these are all the cube roots of unity, okay? Yeah. So basically, when you want to square this, you have to use the a plus b whole square identity. And then from here, well, let's test it out. If you have negative 1 upon 2 plus the square root of 3 upon 2i, square this. You'll get 1 upon 4 plus, plus, okay, this will be 3. Yeah, so I squared is negative 1. And this square will be 3 upon 4. So minus 3 upon 4. Maybe what? Hold on. Minus 3 upon 4. Minus 1 by 2. One second. Huh? What am I doing? I'm tripping myself out. Bro. Holy moly. Yeah. So what happens is, no. It's supposed to be, okay, yeah, so, no, before, no, you can check it out. It works. Just use that in. Okay? So this is the whole explanation. Now look, the primitive means, primitive roots, non-real roots. So basically, the primitive roots of the equation, of the cube roots of unity, the primitive nth roots of unity means the non-real roots. The roots which aren't real. They go in the imaginary number system or the complex number system, okay? Okay, so there's the three roots. I hope you understood the omega. Okay? Now omega is a special name, that's what's given. If you graph on the complex plane, you'll see it out. Okay? Okay? So I'll show you in a bit. I think the next slide I'll show the diagrammatic representation. Because this would I want to focus on the equations of how to solve them. Yeah, so this topic is done. You finish it? Okay? Yeah. And on your homework, this is your task. Verify equal to 1 upon 2 plus the square root of 3 upon 2 I squared equals negative 1 upon 2 minus the square root of 3 upon 2i. This is your homework, okay? And if you know the answer, let me know in the comment section, okay? It's not too difficult. Just let me know the answer, okay? Remember, I do not cheat. I do this on my own, because I'm very smart. Okay. So just do this. Try do the homework. Try do it. Verify that. Okay. Now let's move on to one more. The fourth roots. No, I think I should do the diagrammatic representation. Okay. Now let's do the diagrammatic. So look. So let's represent the cube roots of unity on the complex plane. Okay, so cube roots of unity on okay, let's see. Let's draw a little graph. This is my imaginary section. It's my real section. This is 1. This is I. This is negative 1. and this is negative I. Yeah, basically this is the concept this is the unit circle concept. Okay? It's like this. Like you have something like here, 1, and you have negative I. So we can form a circle like this. It's not the best. I think I should draw it better. Okay. Okay. This is I. This is 1. Okay. This is I. This is 1. Okay. And this one right here is negative I. And this one right here is negative 1. So we can form a circle like this. Yeah, basically, this is not the unit circle. Now I explained the last video what the unit circle is. Basically, in the unit circle, basically, the modulus of all the numbers there is 1. That's why it's so special. It's the unit circle. It's a unit. Oh my god, doesn't look neat. Yeah, my graph. I just draw it. My imaginary roots. Okay. Yeah, so I'll do the 4th roots in the next video. Okay, but for now we'll do this. Cube roots. Let's see. Look. Unit circle. I. Negative I. Negative 1. Oh good. Looks good now. Let's draw a circle. Okay. Then from here. Okay. Then from here. But actually, it should be drawn like this. Like it should be drawn here. Like here. Minus I. Yeah. Yeah. Okay. This is the unit circle. In this case, the absolute value of all the complex numbers will be 1. Because all the complex numbers here are plus minus 1, plus minus I. Okay? So now basically, these are the numbers. Negative 1, I, 1, negative I. Okay? I know it's not the best, but it's just to get your representation. Alright? Now, let's move on to drawing the graph. So the cube roots of unity, we have 1. This is 1. Okay? Then we have is equals negative 1 and 2 plus the square root of 3 I. Now where will this be? Look. It will be between this. This is 0. This is 1. So let's say this is 1 by 2. No, negative 1 by 2, right? Yeah. So here, look, negative 1 by 2. It would be yeah. It would be somewhere here, like negative 1 upon 2. And then the square root of 3 upon 2i. Now where would this be? The square root of 3 upon 2. Huh. So the square root of 3 upon 2. Okay, well, let's look carefully. Okay. So basically what we're doing is so this will be the imaginary positive section. Okay, and like this will be like This is the square root of 3 is 1.73 upon 2. So I would assume it's somewhere like, you have to approximate because it's rational. So I would assume that it's somewhere between like between 0 and 1 in the imaginary section. So this will be 0, 0i, this is I. So let's assume somewhere right here is the square root of 3 upon 2i. Okay? Yeah. Okay guys, I'm back. So I have to fix the graphic of the unit circle because now it looks neat. It's clean now. Okay? So look, basically, look, these are the points. Negative 1 upon 2 plus the square root of 3 upon 2i. Now let's plot the other solution is minus the square root of 3 upon 2i. Okay? So yeah, as I said, the square root of 3 upon 2 in the imaginary section will be between 0 and 1, because 1.73 upon 2 would be like somewhere between 0 point something. So yeah, then it's approximate, okay, because these are irrational numbers. So the graph, it wouldn't be exact, okay. Now we have negative 1 upon 2, and then we have negative. Now we have negative. Now 3 upon 2i. So what can we conclude about this? Now look, the points on this, we can like, what do we say? Like, we can sort of connect the points like this, like this. Like this. So what we kind of made a triangle like this. We connected the points, okay. Also, this is root 3 upon 2i. The square root of 3 upon 2i. Okay. And now, what we're doing is basically like we just create kind of like a triangle figure. We can join these points like a triangle. And that's the thing. This is why they're so unique. And in the next video, when we talk about the fourth roots of unity, or so on, it's gonna be cool, you know? So these are this is why math is cool. The graph and stuff, okay? So I think that's all. I'm gonna see you guys in the next video. The guys just erased my board now, so I'm just gonna clean it up. Man, I'm tired as hell, but I hope you enjoyed the video, and we're gonna have more bangers coming on the channel soon, okay? I hope you enjoyed the construction, how we can join the points. It's pretty cool, you know, how you can graph the points. Okay? Yeah. And one more thing though. Yeah, we can join them, the points. We can represent the points AB. Like if we have 1, it will be 0, 1. If we have something like negative 1 upon 2 plus the square root of 3 upon 2i, the points will be negative 1 upon 2, comma, the square root of 3 upon 2. And it'll be, for the third root, it'll be negative 1 upon 2, negative 1 upon 2, comma, minus the square root of 3 upon 2. Okay? Those are just the coordinates, the points of the complex numbers. It's pretty cool how you can join them. So make sure to do the homework I gave you, just very small. Okay, and if you have any questions, let me know. Without further ado, peace out.